Well, hi, and thanks for joining me in my shop. I'm going to take another run at doing the oscillator and antenna coil, in particular the antenna coil for the AM band. I fashioned up well, that's my loop antenna. After looking at the schematic, I don't think it's too critical what kind of AM loop antenna you put on here. A short circuit would be better than nothing, and the first time I tried to align the front end, I had the antenna terminals actually connected exactly as it states in the manual, except it's a little vague about whether an antenna should be connected or not. And what it says in the manual is via a dummy antenna, connect your signal generator between the antenna connection here and the ground connection here with just a chassis connection. But that's essentially what I did. It's just remains silent on what to do about an antenna. With that kind of connection in place, I was unable to tune the antenna coils properly for the AM band. There was no peak appearing at all. So I'm going to kind of try the same thing with this connected. I think that's what I'm going to try. We'll just see what happens, and maybe in the end this thing will work as a good AM radio. First, I'm just going to try hooking up this antenna, and we'll listen to the radio and see what happens here. So it's been about 3 days since I've been in the shop working too, so let me just check things over. And I have another little spiel I'm going to have to go into about how I isolate my work pieces here while I'm working on them, because of some confusion that's out there that I found in some comments on an old video. So we'll take care of that too. Hey, why don't I take care of that right now? We'll turn on the radio and let it warm up. Okay, so just to start, see my fancy control panel? Yeah, this is just recovered from somebody else's project, and I like the switches on it, so that's why I'm using that. So this arms power into this box, and this selects power to the outlet here, or power to the outlet through the dim lights that are up above. So you'll often hear me snapping these switches without seeing them. The radio's off right now, so if I snap this down, now the radio is ready to be powered. If I turned it on, it would come on, and it would draw its power through the dim light bulbs that I showed up above here. These two dim light bulbs. So I'm just explaining this because I know some of you are fairly new subscribers and you just haven't heard the spiel before, and I just want it to be clear. So usually when I'm turning on the power to the radio, I'm turning it on in this mode. I'm watching those lights even if they're not on camera, and after a second or two I know whether or not there's a short circuit in the radio. 99% of the time there isn't. Then I just flip this switch and full power comes on. Now, just to confuse things, I've got 4 meters to look at here at this point. I got a meter here, I've got a meter here, and I've got this thing. This is really what I think might be confusing some people about what's going on in my shop. So just to explain these meters, this meter is calibrated so that it actually reads percent of full voltage. So you see right now it's way over here. That's 100% of full voltage. So the full 120 volts or whatever it is today is available at the terminals here for my workpiece. Okay, if I had this on dim lights, this would probably read 80%. That's all the voltage that would be available. So that's what's going on with this meter, in case you see it and wonder what's happening. It's not calibrated in volts. Just think of it as percent. So this one over here, this guy is calibrated in volts. Notice the scale doesn't drop to 0. It starts at 100 and goes up to 140. So often this meter will show 0 or look like it's showing 0 if the voltage is below 100. So sometimes you might look at this and think there's no voltage available. Well, yes, there still is. This shows the line voltage coming in my shop. The meter at the bottom there. Sorry, I'm kind of getting in front of the camera. This guy here. So it should always be on, always be indicating whenever, just always on, 24/7. You can see it moving around there a little bit, and all these meters should have followed that motion, but maybe not that one. This guy here, I purchased this 6 months ago. It's a great little device. It reads everything from voltage. Right now it's reading 123. You can compare this to the likes of this meter or that meter. You see this one's out. And this one's pretty accurate. But this of course is the go-to. Look, it's plugged right on the extension cord that brings power for the workpiece. So it's actually reading the voltage right at the end of the extension cord, just before the cord of the workpiece, in this case the PYE radio here. The thing that could be very, very confusing to people is that it's a 3-prong plug here. Okay, but if you look at the back here, the third prong is going nowhere. Okay, it's just hanging in the open here. It's not connected in any way to any ground of any sort. It really shouldn't even be here. It should just look like that. So most of the time I'm working with equipment that just has 2 prongs, and much of the time there's a transformer right in the front of the radio. This is a multi-tube radio, not a 5-tube radio. Has a power transformer, so it's doubly isolated in a sense from the power line ground. So now how's power getting to this extension cord here? Power is, and by the way, what is this? This plug is running this meter here. So it's also picking up the voltage right at the end of the extension cord, just like this one, basically. Except, of course, this is a digital, much more accurate meter. The power that reaches here comes through an isolation transformer. The secondary side of the isolation transformer that's feeding here is not in any way grounded back to the power system, neutral, or anything. It's just completely isolated from the power system, and that's what comes into my shop here. So even if I plug a 3-prong plug into here, the ground plug is connected to nothing. So the most important thing I realized in maintaining safety in a shop like this is not so much having a very particular arrangement. You know, there's some magic, sorry about the focus, there's some magic arrangement of isolation transformer and all this kind of stuff that will make your shop 99% safe. That's not really the case. What's really the case, in my view, is you know the situation in your shop. You know what is going on. You know what is grounded. For instance, in this shop, every other piece of equipment, everything you see, my computer, everything is plugged into regular outlets, 3-prong grounded outlets. So this guy's plugged, my scope here is plugged into a regular outlet, and so is all this other equipment. Some of that equipment is a 3-prong, has a 3-prong plug, so it carries up the green wire case ground onto the case of the equipment, and that same power system ground, or green wire ground, whatever you want to call it, is connected right to the test lead. So I'm aware of these kinds of things, and that's what keeps me safe. Keeps me, well, 99% safe. You're never 100% safe in something like this. But I understand that there can be confusion about what it is I'm doing and what's going on in my shop and the like. So don't worry so much about my shop. Worry a lot about your own shop. I have been surprised in the past. I've gone from being quite certain about how things are operating in my shop to suddenly discovering that, in fact, things aren't the way I thought they were. And that's got to be the most dangerous situation you can get into. And since I, like lots of people, am working with partial knowledge, who is working with full knowledge on everything, I'm not so sure. There's always a chance of a misunderstanding leading to some kind of some kind of shock, basically. Just further to that, I stand. These are my slippers. They are rubber soled. That's what I wear in here. I do not come in here in sock feet. The mat I am standing on has a rubber backing also. So even if I did come in here in sock feet, I'm still, as long as I stand on my mat. Beyond that is a tile floor whose conductivity I don't know and I'm not about to test. But there's a fair number of things keeping me from getting shocks. Do I get shocks? Yes, I get a couple a year in here. They're almost always related to 2 parts of the same radio I'm working on. Pretty hard for me to get a shock to ground, but yes, it can be done. The moment I connect any piece of equipment with a 3-wire ground, like these guys here, these are the test leads from the bigger test equipment in my shop. As soon as I connect it, I have set up a scenario for getting a for getting a shock to ground. So anyway, enough of that. I'm not here to lecture. I'm really not trying to teach anybody anything about doing this. I really only want to go so far as to explain what I'm up to. Am I following standard textbook procedures? Fat chance on that. I'm probably close, but may not be right on the money. But do I get a satisfactory result? Yeah, I think in most cases I persist until the result is satisfactory, even if I stumble around a little bit here and there, and occasionally have things a little crazy, like not having this antenna connected. So sorry for the speech. I felt I had to do that. Some of you know this story already because you've been watching my videos for a long time. Let's see if I can just make this so it can be hung easily here. Didn't I say I was going to turn on the radio and let it warm up? I never got around to that. Okay, so let's do that. So you just watch all these meters go. When I first turn on the power, here's what's going to happen. Let's see if I can get the lights in view too. I don't think I can get the light. I can't get the lights, but you'll just have to trust me on this. When I first turn this radio on, with this switch in the down position, the power coming through this goes through a couple light bulbs on the way. So here's what you'll see. You'll see this drop down. You'll see this probably disappear right off. And you'll see this meter shouldn't move, and this one should start showing the actual voltage being supplied to the radio. Are we all ready? I think we're ready. Oh, one more thing. If you're not game, because I'm kind of explaining this to who I assume are those who aren't familiar with dim bulb and all this kind of stuff. Because some voltage is being lost across the bulbs, this will show a lower than supply voltage. It might show 90, 100 or something like that. And you'll see it vary. When I first turn on the radio, it'll drop way down. Better to watch this meter maybe. It'll drop way down. It'll come back up fairly quickly. It'll sit there, and then it'll slowly go down again. So what's happening is you turn on the meter, there's an inrush of current causing a big voltage drop in the dim bulbs. The inrush into the heaters stops as the heaters heat up. Voltage comes back up because the voltage drop on the dim bulbs has gone down. Then once the heaters get heated up, the B plus is developed in the radio. That turns on the tubes. They start conducting current, and the current they conduct causes again a voltage drop in the dim bulbs, and you see the supply voltage start to go down. So that's kind of the pattern. I look for this all the time. I don't comment on it when I'm starting stuff up. I'm watching for it. I'm watching for all these things. Probably many of you are too, just to make sure everything's normal. So here we go. We'll turn this on, see if I'm a liar. Oh, and you've witnessed me make my most common mistakes. I forget to plug the item in. Okay, we're in. Can you see all these meters here? There we go. Okay, this time I'll turn her on. There we go. Okay, so the dim bulbs are on. They just went through that cycle I described pretty quick. Why is this saying nothing? And I bumped something here. Yeah, I must have bumped the setting across here and accidentally turned it off. So there's the actual voltage, 89, 88, 80, going down. So now the radio is fully operating. It's pulling as much power or current, or it's providing as much load as it can. And you can see, I'll show you my dim bulbs. That's this and this are glowing because they're stealing some of the power, I guess you could say. So now I'm happy, everything is good, nothing funny happening. Let's listen. The radio's actually working, but we're going to go to full power. Watch my meters jump here. There we go. So now we're at 122 volts, a little high, and everything is glorious. Let's hear it. There it is. Glory. Okay, there we go. So sorry to have dragged some of you through that who have seen it too many times. But I suppose I should do that once in a while just to make kind of clear how it is I keep myself relatively safe in here. So, next, make sure we're on the AM band here. Okay, we're on the AM band. Very crummy noise. Now I'm going to hook up, before I hook up the little loop antenna, I'm just going to hook the outdoor antenna onto this terminal here. Turn down the radio. So I want to compare. So here's what we get from the outdoor antenna. One loud buzz. Well, not quite. There's a little more to it. Do we get any stations? And I think the answer is no. So in my imagination, what I'm thinking is the front end of this radio is not tuned on the AM band. I couldn't tune it without some kind of antenna connected. And because of that, it's basically letting everything into the front end of the radio, all this noise and hash and stuff like that. And if there is a radio signal making it in here, it is so relatively weak, we can't even hear it. So I'm hoping I can hook up this antenna, tune the front end of the AM band, and give those weak radio signals a chance in light of the strong interference that's here in my shot. Okay, so let's hook up the antenna and we'll see what happens here. Not doing this with any kind of signal really, because like I'd love to be tuned to a station. Now we may do this a couple of times in a couple of different ways. So first, off with the outdoor antenna. Okay, and I have no idea if this is the right amount of wire, the right size of loop. I'm sure it isn't. I'm sure the loop is probably similar in size to the radio cabinet. But, you know, this is what I got, so let's use it. So, first of all, on the antenna here. Oh my gosh, I think I just... Clip leads. Can't live with them. Whoa. Should have went more quiet than expected. Wow. Well, I mean, this is essentially a short. Hard to imagine how that's ever going to receive anything. Turn her way up here. But I may have activated the adjustable coil in here in a sense, and that coil may be so far out. I have the radio practically up full. Well, it seems to be at the bottom of the dial, it seems to be a lot more sensitive, so that suggests to me that coil is simply in need of a tune-up. That would be this coil up here. So coil and capacitor involved. Just doing this based on the noise. There we go. Goes quiet there. Here a bit here. Needs to be anywhere below that. Doesn't quite sound like a peak to me. And now we have this capacitor up here, which I'm just going to manipulate the capacitor directly here rather than try to... Oh, I think it's cranked down tight. Yeah, it's cranked down tight. You gotta loosen it up. Let's loosen it up. Yeah, that's the microphone right there. So you heard the radio go quiet. None of this is a good sign. Back to the coil. Well, a little something there. So I'm going to give the radio something to work on. I'm going to get my signal generator here, providing a signal. I'm going to do it indirectly. Just another this guy here, one of these wires. Okay, I don't know. Let's try a couple. Once we get it going, I can figure out which ones to use. A little more certainty. Okay, we'll see if we can pick that up. So the radio is tuned to, I think, the low end of the AM band. It's just about where the signal generator is. Okay, volume's up full blast on the radio. Well, it can't be 460. That's off the band. Well, okay, maybe it's at the top of the band. 460, that was 455 leaking through. That's what that was. Leaking through the IF. Okay, I must be at the other end of the band here. The easiest thing for me to do is tune the radio. Set this to, let's say, 700 or so. Tune the radio. Nothing. Okay, so we have 30% modulation at 1000 hertz. That's what we should hear. Not a thing. Okay. I wouldn't think an inch would make that much difference, huh? Tune it in. Tune it up. Okay, there we go. Okay, way out here I can hear it going down. This is certainly not a peak. Capacitor. It's making much difference here. That's the bottom. it's full volume too, so I mean this thing is receiving nothing. So I'm suspicious now that this is doing nothing but basically shorting out. Pretty much shorting out the antenna with this. So what that suggests to me then is there's a much more substantial coil associated with the antenna. Something more like this, of some sort. So why not try using this? Okay, so I'll identify. So this is two coils here. These antennas, normally two coils. One with a lot of turns, one with a few. I want to take the one with a lot of turns here. And that would be this wire and this wire, I'm pretty sure. Oh, sure. Not so sure. Maybe probably this wire and this wire. So clip to one, clip to the other. Now I think that's the bulk of this coil here. Where'd it go? Oh, I'm holding it up to nothing. There's no antenna there. So what we'll do is we'll connect this antenna, these two terminals here, to the radio, and we'll try again. Okay, two outside terminals. Wait a minute, not the two outside terminals. Don't be fooled. It's this and this. Don't be fooled. I think I got it. So, not that I need to hook up the signal generator to it. These two are going to be the antenna terminal connection here. Now, do I think this is going to really help? I don't know. We'll see. It's quite different from the first coil. Oh. Right. We know the clip lead works good. Hey, how do you like that? I got my fingers on this. Just set that over here. It really likes my fingers. That's an indication maybe of a lack of tuning. Okay. Let's see what we got now. Maybe I can find a better spot to tune to here. Wow, that really does sound like motorboating in the radio. This, if it is, there's no use trying to tune this with. There we are. No sensation of anything peaking there at all. Let's try the capacitor here. uses a split bolt, split nut rather. I almost swear I... Okay, so anyway, never mind that. The capacitor is now loosened off. And like nothing happened. Nothing happened. Let's give it a little signal here. So what I'll do, make use of this loop here. Okay, so that's now the antenna on the signal generator. Crummy as that must be. We're still on 700. Let's see if we can find it. Sounded pretty good down there, even though it's just noise. Wow, what is that? It's like a woodpecker. Oh, where's my signal generator? Okay, so I'm just going to look at the scale in the radio here. Okay, it's low at the top, high at the bottom. So we're at the high end of the band here. $13.40. Okay. Now, of course, if I'm going to peak this up with this particular coil on it, I'm going to need this particular coil all the time. I'm sure it's specific to the antenna. Let's see what happens here. I don't sense any change whatsoever. Nothing at all. Nothing. Nothing, and nothing at all. Didn't make any difference whatsoever. So why would that be? Let's just double check, make sure I've really found a coil connection here. Yeah, you see the voltmeter or the ohm meter drop to 0. Definitely found the coil here. Well, not sure what else I can try. I mean, I've gone two extremes. I've gone for the hardly any wire in the antenna to the pretty busy little coil here with many turns. Nothing is making that coil capacitor combination resonate up here. So I don't know. I think I'm going to leave it just like that now. Go back to what I was saying so long ago. I don't really care about the AM side of this radio anyway. It's all about shortwave. But because of some encouragement received from some of you, I thought I would give that a shot. there's my shot. That's my shot. So next thing is to seriously try to align the shortwave now. Shortwave bands. And say goodbye to the AM side of this radio. Unless I can discover what the antenna really looks like, and I have spent time on the internet looking for photographs. There's photographs of this radio and similar radios. None of them show the antenna. So I don't know. I don't know what it looks like. There's no information. I've studied the schematic again and again and again. There's no hint in there as to what this might be. So there we go. I'll leave it at that. And it's time to do the shortwave bands themselves. Thanks.